Here is one interesting example here about one example about traveling to Mars and how can we do the rough plan for this country. Planning of orbits. Okay. So again, we assume the this is the Earth's orbit, and this is the center of the Sun, and we assume they are in perfectly circular orbits. So this is Mars. They both are circular because here we just learned the Hohmann transfer. We assume they are circular. Okay. So the question is this: if say in certain time, they say for reference, say at a particular moment, Earth is here. Okay, and if our mission is to take the most fuel efficient way to get the space shuttle or the cruise to land on the Mars, or at least to meet Mars in space, how can we do it? We must launch everything in a particular time in a year, otherwise we're going to miss it. Assuming we take the fuel most efficient way, then basically is the way we take the Hohmann transfer. Okay, so hopefully our goal is this. Hopefully the space shuttle or whatever the vehicles going to rendezvous with Mars at this point, and let me call the transfer point to here. So here we take the Hohmann transfer. That means we take the half cycle of this period, this orbit. And for this one we have we can have information. So the Earth have the distance to Sun, and that one is we call the 1 du. Okay, and the distance to the Sun. Okay, and for Mars, and the distance average is 1.52 du. So basically, let me say this is R1, this is R2. Okay, so that is R1, and this is R2. Okay? So the same thing we repeat, and here you should be able to calculate with R1 and R2. You should be able to determine what should be the appropriate data V, and also data V1 here and data V2 here. Right? So from the previous exercise, allow me not to repeat the calculations, but you can plug in the numbers. But here I want to talk about is when is appropriate launching time, and such that once at this moment we launch the things here, then we will go there. How to think about this one? We think about it is this: once we on the transfer orbit, how long it would take? It takes half cycles of the orbit. So basically, is this the half of the elliptic transfer orbit, the half period. And earlier we have the equations, and we do the equations, we implement the equation with those numbers. The half period of this one is 0.708 Earth year. Okay, I've done certain calculations, so that is the number we have. With this number ready, and now the question is when we need to launch the vehicles. When? So that means here, the when is when we talk launch here, then say the Mars is here. So they spend the same time Mars moving on onto his own orbit, and this vehicle moving onto the terrestrial orbit. They at the same amount of the time they will meet here. Is that right? The concept is very straightforward. And how to determine? And we can determine is this for distance. So sorry, here let me say the period. For Earth is 1 year, 1 TU of the say the one Earth year. In terms of Mars, the Mars has 1.874 the Earth years. Okay, so that is a period. So that means right now we want to determine, we have known the vehicle going to spend that much time on the terrestrial orbit. That is the same amount of time the Mars moving from there to here. Okay, so then from here we can determine how much the angles here. The angle, basically the time spent from here to here is 0.708 here, and divided by the whole cycle of the Mars is 1.874 year. So from there we can determine, multiply 360 degrees, and that number is 136 degrees. So that means we can determine this is 136 degrees. So from here we can calculate, we can determine the relative positions between the Earth and Mars. That is a specific relative position, then we have to launch. Otherwise we're going to miss the windows. If we miss that window, then we have to wait for the next window coming up that satisfies these conditions. Okay? Okay, so that's one. I think this is a very interesting examples, and that can inspire a lot of the thinking. Of course, in the mission planning, they won't directly shoot the vehicle from the surface of the Earth right away onto the terrestrial orbit. No, in reality, it's not in this way. In reality, they will shoot the vehicle onto the lower orbit, lower Earth orbit. So that means circulating to the certain moment, then they begin to do the transfer. Okay, so that means all the things will be included in the mission planning. That is the more complicated procedures, but the big concept is like this. Okay, so that is an example here.